If you want to sell online, make sure you stand out. Go to Wix e-commerce and create a professional online store that will grab shoppers' attention.
How do we solve a system of linear equations using matrices and determinants? How do we solve for the values of x and y here? So one way is by solving them using one of the regular techniques we have seen, or we can use matrices to solve them. Yes, matrices. To solve the equations using matrices and determinants, we first need to write them in the matrix form. So we first write the matrix of the coefficients. For the first equation, the coefficients are 2 and minus.
Okay, morning class. Can you all hear me?
Can, sir.
Can Okay, good. So I hope you can wake up, call your friends. Okay, morning Atika. Morning Haziq. Okay, Atika, good. Okay, good morning Firdaus. Good morning Hatta. Okay, those in Zoom, I hope you all can hear me. And those in YouTube, I hope you all can hear me too. So yeah, today we are going to study matrix. So please be ready with the notes. I already sent the notes in the group. Okay, actually the notes are also online lah, so no problem with that. Okay. So I think everybody can see the screen of the note also. In few minutes we start now. In 3 minutes time we will start. So please, if your friends are not here, you can wake up your friends. Ask them to wake up. It's already time to study. The weather in Malaysia is quite good today. Okay, it's raining everywhere. So yeah. Okay, good morning, Fatin. Okay, left around one more minute, but the amount of people in the class is quite little. So if you can, please ask your friends to wake up and start join the class soon now. Okay. Now, ready, everybody? So, morning. We are going to start the class right now. I think I've waited enough. 8 o'clock already. Okay. So, yeah, let's start lah. Okay. Now, matrix. Okay. Now, what is matrices actually? What is the importance of matrices? Actually, matrix has been used in many systems. It's one of the most important topic which you have to study when you go to A levels, or even you go for what is this called? Engineering, or when you further your studies in economics. Okay, especially economics, they use metric system a lot lah. Actually, metric system is being used every day by people. Even right now itself, when we speak about it, metrics is being used, such that when we want to put the banner, we want to put the notes online and everything, all that is called metric system. If you see my web page, including my web page also is under metric system. Why? Because the web page there, they have the what notes, and then under notes will have like the sub notes. So all that is under metric system lah. Okay. The arrangement of a layout of a web page is based on a metric system. It's based on calculation. Okay. But that's said and done. We are not going to go into that detail, but we are going to study a little bit more interesting stuff about matrices lah. Okay. The calculation lah, the basic calculation behind matrices. So today's lesson is not that heavy. It's quite easy and it's quite interesting. Okay, it's quite easy and quite interesting. It's not a very heavy lesson. It's a very simple lesson. We have 4 topics over here to cover. 4.1 is matrices, determinant of matrix, inverse of matrix, and 4.4 is the system of linear equation to solve 3 variables. Okay, now what we're going to cover today, maybe we try to cover 4.1 and 4.2. Hopefully we can cover that. Okay. And under matrices, we need to know the type of matrices lah. So before we can move on, we see the type of matrices which we have over here. Okay. Now, if you look over here, the type of matrices which we have over here, the first one is a matrix, which is a rectangular array of numbers arranged in rows and columns. Okay, rows and column, which is enclosed by a pair of brackets. So this is the bracket which we are talking about. Okay, this is the bracket. Okay, here is the brackets line. You can see the brackets. All these are the brackets which you are talking about. And this is the rows and columns which you are talking about. This is your rows. Okay, and these are your columns. You can see that? Okay, so rows and column. You can see that, right, everybody? Okay, so any order of a matrix will be written by rows and columns. So this is order of 1 by 1. This is order of 3 by 3. Why? Because 3 rows followed by 3 columns. And this is order of 2 by 2. This one you got studied before in Form 5 lah, maths. Am I right? Under math chapter, you already studied this already. Clear? Okay. So you have studied this before lah. Okay. Now, after we know how to see the order and we know how to see the rows and columns already, we need to know that this A here represents A11. The first row, the first column. If I write down the Q over here, this represents A. Oh, the second row, second column. Okay, but if I write down R over here, this is going to be the second row, third column. Understand? So A, 2, 3 lah. Understand? A, 2, 3 over there. So I hope until there you all understand that. Clear? The first one is row, then only column. Okay, first one is row, then only column. I hope everybody okay lah. Okay. If okay until there, we move on some more. Here we can see more in detail. The order is written as M times N. The M is the row. The N is the columns over there. So this is the columns. And these are the rows. Okay. A matrix is read with row first, then followed by column. So it's RC line, RC. Okay. How you want to remember? You can have many ways to remember lah. Okay. I like to remember if you row your boat, then only you will get a column of success. Okay. If you row your boat, then you will get a column of success. Your boat is study lah. Okay. Your boat is to study. Okay. So once we get that ready, we know what is row and column ready. Okay, and I already told you how we can put the elements. We can label the elements over here. Okay, second row, third column. Okay, second row, n column, or third row, third column, third row, second column. Okay, so you can see how we label the elements over there. I and J. I stands for row, and J will stands for column. Okay. So I hope until there everybody okay lah. Any problem until there so far? Can understand? Okay. Now we carry on. If matrix has m rows and n columns, then it's called m by n matrix. Is what we say m by n matrix. Okay. And this m by n is also known as the order of the matrix lah. It's also known as the order of the matrix. So if let's say we have 4 elements over there, 2 rows, 2 columns, then therefore this will be a 2 by 2 matrix, or the order is 2 by 2 lah. Okay. And we have 4 elements over there. The elements is A11, A12, A13, A21, A22. Okay. If I give you like this, A11, A21, A31. This is going to be a 3 by 1 matrix. And this is the order lah. Okay, 3 by 1 matrix. Of course, all the elements over here are this lah, A11, A21, A31. That will become the elements of the matrix over there. Okay, this will become the elements of the matrix over there. So I hope that is clear lah. Okay. Okay, we carry on. So they ask you, what is the order of this matrix over here? Very easy. 1 row, 2 row, 3 row. So 3. Okay. And then 1, 2 columns. So 2 lah. So if I just draw a bit extra, 1, 2, 3, this becomes 3, and 1 and 2. So this becomes 2. So we have to write R times C, row times column. Okay, row your boat to get the success. Okay, here also 1, 2, and then 1, 2 over here. Okay, so you can see very clearly that this is going to be 2 by 2 because 2 rows, okay, and 2 columns. Understand? 2 rows and 2 columns over there. Can you all understand until there so far, class? Any problem?
No, sir.
Okay, good. How about C here? C here is 1 row. Oops. C here is 1 row. Okay, 1 row there, and 2 columns over here. So you can see 2 columns over there. Yes or not? So that's why it's 1 by 2 also lah. Okay, 1 by 2 or 1 times 2 over there. Can you all see, right? 1 by 2 or 1 times 2 over there. Any problem under here so far? Can everybody? Okay.
No problem, sir.
Okay, very good. And D there, the last one there, we can see that this is going to be 1, 2 rows, 1 column. So 2 row, 1 column. So 2 by 1. Okay, 2 by 1. So it's easy. It's not a very heavy lesson live today. Today morning is quite a easy lesson there. Okay, then we have all these type of matrices over here. The column matrix, the row matrix, the null matrix, the diagonal matrix, the identity matrix, and lower triangular matrix, including upper triangular matrix over there. So all these matrices over here will definitely play a role. Okay, will definitely play a role over here. Okay, now let me just wait. Just let me just stop the share for a while. I will share back in a while. Okay, hold on. Okay, just give me a second now. Just to make sure that you all can see the proper things. Okay, so I share back again. Hold on now, everybody. Just a while. Okay, so yeah. Okay, now you all can see back the screen, right? Again, okay. So hopefully it'll be better right now, lah. Okay. Now the type of matrices over here is we have like column matrix, and then we have row matrix, the null matrix, diagonal matrix, identity matrix, lower triangular matrix, and also upper triangular matrix. Okay, so we have these few matrices over here, which we have to take note lah. Okay, which we have to take note over here. Okay, so let's see the first one there lah, column matrix. Okay, we are going to see the first one, which is the column matrix. Okay, under column matrix over here, you can see that. Okay, we can see that that with the column is only one column. Okay, one column, and there are many rows lah. Okay, there are many rows. Despite having many rows, we call this a column matrix because there is only one column over there. Okay, because got one column, so we call this as a column matrix. Okay, so it's M by N then. Okay, M by N. Okay, so Muhammad Amirul, you asked me that, is there any limit when using this matrix? Of course, there will be a limit. The limit is N lah. Okay, so it's not infinite, it's N. Okay, but you can increase the amount of matrix you want to use up to you, understand, based on whatever we want to find. So that's why that's the benefit of matrix lah. Okay, that is the benefit of matrix over there. Okay, I carry on some more. Now this is an example of column matrix over here. You can see 1 row, 2 row, 3 row. So from here we have 3 rows over here, and therefore this is order 3 by 1. Okay, 3 by 1 matrix over there. And if you look at B there, okay, if you look at B, we have 1 row, 2 rows. So the order here is going to be 2 by 1. So it's a 2 by 1 matrix over there. Okay, then we go on some more with the row matrix. Since the column matrix only had one column, so the row matrix will have only one row lah. And we have many columns, understand? And we have many columns. So from here we can see 1, 2, 3 there. Okay, so this is 1 by 3 matrix. Okay, 1 by 3 matrix because 3 columns over here, but 1 row only. So 1 by 3. Okay, again here is 1 row followed by 2 columns. So 1 by 2 matrix. Okay, so that's how we see row matrix over there. I hope until there everybody okay. Any problem until there so far? Can okay, let's carry on some more. Now we have the next one, which we call as the zero matrix. Zero matrix means that the matrix, all the elements in the matrix is zero lah. All the elements in the matrix is what? Zero. So that's why the zero matrix can be any order. Okay, can be 3 by 3, 3 by 2, 1 by 1. Okay, 1 by 2. So it depends on the question they give you lah. Okay, but zero matrix is basically useless lah. Okay, it's not that much useful because anything you times or plus, it doesn't have any effect. Okay, so zero matrix is A plus A and B here are zero matrix with all the elements 0. Okay, then the next one we have is a diagonal matrix. Now, diagonal matrix is the interesting part. They say a matrix where element of the matrix is 0 except of the major diagonal. Now, what is a major diagonal called? A diagonal matrix must be a square matrix. Okay, must be a square matrix such that m equals to n. Why? Then only you can get a major diagonal. For example, if you have a matrix over here and this is a square, then this is called the major diagonal. Understand? This part here will be called the major diagonal. So this part here should be all numbers lah. Okay, all should be numbers besides the what is this called? The other elements over here all will be 0. Okay, all the other elements over here will be 0. So we can see lah. Okay. If you look over here, A here is a diagonal matrix where 2 and 3 are the elements which are not 0. Okay, and 0 and 0 is over here. Okay, B here also is a diagonal matrix. You can see that. Okay. So from here you can see that this major diagonal is not 0. C here also is a diagonal matrix, but even though one of the element over here is 0, that is not a problem. Cannot be everything 0. If everything is 0, then it becomes 0 matrix. Okay, for example, D here, if this becomes 0, then this will be a 0 matrix. Huh? Understand? This will be a 0 matrix. But if since here is 3, here is 3, yes, not. So therefore, it's not 0. So this is not a 0 matrix. Understand? If there is 3, then it's not a 0 matrix. But if every element over here is 0, then it will become 0 matrix. I hope that is clear for everybody. Lah. Okay, I hope that is clear for everybody. Okay, let's carry on some more. The next one is called identity matrix. You have seen this before. You see this in your Form 5, remember? Okay, under identity matrix, where they tell you that the leading diagonal is 1. Okay, the leading diagonal is 1. So here is the leading diagonal. So here is 1, 1. Okay, here is 1, 1. So the leading diagonal is 1. The rest all elements are 0. Okay, the rest all elements are 0. So that's why this is called the identity matrix over there. Okay, an identity matrix also have to be a square matrix, which is m equals to n. Okay, an identity matrix also must be a square matrix, which m equals to n over there. Okay, now identity matrix is very, very useful. Lah. Why? Because after this, you'll be able to see that identity matrix is what will give us inverse. Understand? Identity matrix, which is what they will give us inverse. So this metric is very, very useful over here. Okay. There is some beauty about diagonal matrix over here. If you really see over here, diagonal matrix, there is something which is very interesting. Okay, a diagonal matrix, okay, the determinant of a diagonal matrix can be 0. Understand? The determinant of a diagonal matrix can be 0. Then it will not have an inverse. Okay, it will not have an inverse. Okay, never mind. Later you will see more detail later. Okay, next one there is 6. Okay, let's look at number 6 over here now. Number 6 here is a lower triangular matrix. So what is a lower triangular matrix? Lower triangular matrix means all the upper elements are 0. All the upper elements are 0. And if it's a lower triangular matrix, it will be the lower elements are 0. Okay, this is a lower triangular matrix. This is a lower triangular matrix, and then later you have upper triangular matrix. So under lower triangular matrix, the above elements will be 0. Okay, under upper triangular matrix, the below elements will be 0 over there. Can you see that? The upper side of the matrix is a triangle. The upper side of the matrix is a triangle. Clear? It can have elements of 0 inside the triangle, cannot. Okay, but the lower triangular, the upper triangular, the below must be 0, and the lower triangular, the upper must be 0 over there. Okay, again, this is not that important. It's just names of matrix which you should know. And here is a summary which is already inside your slides, which you can see. Okay, so please know all the names of these matrices. Okay, please know the names of the matrices over here. Okay. Then we carry on some more. Okay, we carry on. Next one is operation of subtraction, addition, scalar multiplication, and multiplication of two matrices. So I think addition, subtraction, and scalar is quite easy. It's not that hard. If you look over here, A plus B over here, as long we know that the order is the same, it can be added and can be subtracted. Okay, hold on now. I think the screen is lagging a bit. I know that. Okay, so hold on for a while. I let the screen come back to the normal space. Okay, hopefully now it's better. Okay, so under addition and subtraction here, you can see that there are A, B, and C over there. Yes or not? Okay, there is A, B, and C over there. So for me to move on here, A here, you can see, okay, for A here is going to be 1, 2, 3, 4, plus with the B there, 4, 3, negative 5, and 6. Okay, can you all see or not? Is it lagging very badly? Now you all can see, yeah. Okay, hopefully now better. Okay, so since the order here is 2 by 2, here also is 2 by 2, and here is 2 by 1. Okay, here is 2 by 1. So A and B, I'm very sure I can plus and minus lah, because the order is the same. So from here, I straight away get 5, 5, negative 2, and 2 then. Okay, done. If A minus B also, I can do, no problem. Why? Because this is 1, 2, 3, 4, minus with 4, 3, negative 5, 6. So 1 minus 4, negative 3, 2 minus 3, negative 1, 3 minus minus 5, 8, 4 minus 6, negative 2. So straight away you get your answer already. But if A plus C here, this cannot be performed lah, can't be done. Why? Because the order is different. Since the order is different, you can't do the addition lah. Okay, since the order is different, you can't do the addition. Okay, so I hope until here everybody clear lah. Any problem until here so far? Can?
Can.
Okay, very good. Let's move on. Okay, that was the solution over there. Since here, so very clearly they say since A and C have a different order, so we can't add or multiply. Okay, next one is what we call scalar multiplication. So under scalar multiplication is more interesting. Okay, they say that any scalar or any constant, okay, any constant when it's multiplied by a matrix, okay, you just take the constant and you just write inside lah. Understand? Okay, so Jinsuan asked me just now that for C there, write down no solution. Yes, correct, Jinsuan. You just write down no solution over there lah. Okay, you just write down no solution over there. Clear, Jinsuan? Okay, very good. No problem over there lah. Okay. Okay, any more problem there? Can? Okay, I move on. Okay, so I hope I answer your question. Now, scalar means just multiply lah. Okay, just multiply. So if we look at example number 2 over here right now, we can see that if let's say it's 3A, then this is just 3, 3, 8, 1, 7, 1, 3. I multiply inside lah. Okay, I just multiply inside. So I'm going to get 9, 21, 24, 3, 3, 9. That's it, done. Of course, no need to show all this line. We don't need to show all this, okay? But of course, we have to know lah, okay, what is going on over there. So that's why I explain to you all a bit more detail there lah. Hopefully, okay lah, okay. Of course, scalar can be negative number also. It can be negative constant also. Maybe I give you 3, 8, 1, 7, 1, 3. Maybe I put negative 5, one negative 3 line. If not, the numbers would just be negative of the numbers above. So if I put negative 5, this is very obvious. This is negative 15, negative 40, negative 5, negative 35, negative 5, and negative 15. So it can be a negative constant also. Okay, not necessarily must be a positive constant over there lah. Okay. Okay, let's carry on some more. The next one is more interesting, which is called the multiplication of two matrices. Now, under the multiplication of two matrices, this is only possible, okay, if matrix A have the order of m times n, Okay, and matrix B have the order of n times P, such that the order over here is the same. Must be the same. Then the matrix can multiply and give me the order of m times P. Understand? Then it will give me the order of what? M times P over there. So the final product will have the order of m times P over there. Clear until then? Okay, that will be the final product. So let's see A here. Okay, let's see one example over here. You can see that A here have the order of what? 1, 2. So 2 by 3. 3 columns, right? So 2 by 3 over there. Okay. And B here have an order of 1, 2, 3. So 3 by 2. Okay, 3 by 2. So if I want to multiply A and B, can, possible. A and B is going to be 2 by 3 times by 3 by 2. Yes, not the order. So the final product is going to give me 2 by 2. Okay, the final product is 2 by 2. Now let me just do this ourselves lah. Okay, ourselves means not looking at the solution here because it's a bit confusing looking at the solution here. Okay, I show you one way which you can do faster and easier. So if you look over here, A here, okay, A there is given 1, 2, 3, negative 2, 0, 5. Okay, so if I write down like this, okay, I know that the first thing which I'm going to put over here is going to be 1, okay, row, and then column. See, I circle this way. Okay, hold on now. Things coming up. Okay, this is your row, and this is your column there. So you already get your row and column over there. Okay, so now I'm going to write the row first. Okay, 1 bracket plus 2 bracket plus 3 bracket. Okay, plus 3 bracket. Okay, that is the first row. Okay, then the second row there is going to be negative 2 bracket plus 0 bracket plus 5 bracket. Okay, that is for the first row lah, and the first column. Okay, so the row over here also you put like this, 1 bracket plus 2 bracket plus 3 bracket. Why? Because got 2 columns, right, at B there. So you follow, you ready the thing lah, negative 2 bracket plus 0 bracket plus 5 bracket. Now only we go and substitute the column inside. So if I substitute the column, the first column I substitute inside here lah, like 2, negative 3, 2, 2, negative 3, 2. The second column I substitute inside here, 1, 4, 1, 1, 4, 1. Can I understand until there so far, class? Everybody okay?
Okay.
Okay. So from here, straight away, you can tell me that here is going to become 2, negative 6 plus 6, negative 4 plus 0 plus 10, 1 plus 8 plus 3, negative 2 plus 0 plus 5. So the final answer here is just going to be 2, 9 plus 3 is 12. Negative 4 plus 10 is 6, and the last one there is 3. That's it, done. You already get your answer. Can you all understand that? So this is a safest way for you to find the multiplication of matrix. Okay, safer way to find the multiplication of matrix. Okay, of course, by knowing this extra thing, 2 times 3 and 3 times 2, you know here is 3 and 3. So the final answer is going to be 2 by 2. This will actually lead you to the answer also. Okay, this will lead you to the answer also. Easier lah. Okay, a little bit more easier. Okay, now let's see the next one there. Can I do B times A or not? If I ask you, can I do BA or not? Let's see, BA. Okay, if BA, this is going to be 3 by 2, then 2 by 3. Yes or not? Okay, BA is going to be 3 by 2, then 2 by 3. So I can do lah. Why? Because the order of BA is the same. Over here, 2 and 2, right? Not. So the final order is going to be 3 by 3. Okay, so if I want to do, I can do, not say cannot do. Let's see how. Okay, let's say we got the matrix A and B here. So BA, okay, B there is 2, negative 3, or instead of writing this already, we know the matrix already, right? So I think I'm just going to write this way, straight away. BA. First the row, row. 3 rows there. So all together got 3 rows. Yes or not? Okay, all together got 3 rows. So let's see. Okay, 3 rows there. Correct graphic. We can do cost the same. Okay. So from there, we see 3 rows over there is going to be 2 bracket plus 1 bracket. Okay, got 3 columns. So you have to ready 3 times 9. Okay, if I write down big like this, not enough space. Plus 1 bracket, 2 bracket plus 1 bracket, 2 bracket plus 1 bracket. You all got what is this called? A4 paper, easier, right? Not? Then negative 3 bracket plus 4 bracket, negative 3 bracket plus 4 bracket, then negative 3 bracket plus 4 bracket. Okay, now some people find this easy, but I find this a little bit tedious. So what I can do is I also can write down like this. Okay, I find this a little bit tedious, a little bit leceh, yes, not? Okay, a little bit leceh to write down like that. So what I do is I write down like this. Okay, this is your row, this is your columns. So I do 2 times 1, 2 times 1 plus with 1 times 1. And then after that, the next column, the next one there is going to be 2 times 2 plus with 1 times 0. Okay, the next one there, 2 times 3 plus with 1 times 5 there. 1 times 5, we all know, right? It's 5. So just write 5. Okay. If I go on to the next row there, next row is going to be negative 3 times 1. So negative 3, okay, plus minus with 8, sorry. Minus with 8, 4 times negative 2. Then negative 3 times 2, negative 6, 4 times 0 is 0. Negative 3 times 3 is negative 9, 4 times 5 is 20 there. Next one there, 2 times 1 is 2, minus 2, okay. Then 2 times 2 is 4 plus 0, and 2 times 3 is 6 plus 5 over there. So from here, very obvious, 2 plus 1 there is 3, 4, 6 plus 5 is 11, negative 11, negative 6, and then 11, 0, 4, and 11. That's it. That's the final answer there. Can you all see that under there? And it's very obvious it's a 3 by 3 matrix also, right? You can see it's a 3 by 3 matrix. So the first column, when you times with the first row, first row, my mistake. First row, you times with the first column, you just times the first element with the first element, the second element with the second element, and you plus. And you plus. Understand? Okay, so I hope until there can. Let's look at another one more example over here. Example 4 here. This is more interesting. This is a 3 by 3 and this is a 3 by 1. So I know my final answer is going to be 3 by 1, means 3 rows, 1 column. Yes or no? So if I want DE, okay, DE here means DE row and then column. Okay, row and then column. So if I look row there, straight away, very easy. The first row with the first column there. So 2 times 3, 6. 8 times 3, 24. 8 times 1, 8. I cannot go to the next column. Don't have, right now, don't have next column. So just put that. Plus everything and stop. Okay. Let me get the screen back on track again. Okay. The next one there is going to become 3 plus 21 plus 9. Oh, sorry, my mistake there. It's not 21, right? Am I right? Okay, what is going to be? 1 times 3, 3. 7 times 8 is 56. Plus with 9. And the next one there is going to be 3 plus with 40 plus with 4. So now from there, I'm very sure all of you all can calculate. So 38. Okay, and then 9, 12. 12 over there. 8. 68, if I'm not mistaken. Okay. So the next one there is going to be 7, 47. This is your 1 by 3 matrix. Sorry, 3 by 1 matrix. You can see that 3 rows and 1 column. So knowing the order really helps you a lot, Okay, knowing the order really helps you a lot. So I hope until there you all are okay. Any problem until there so far, class? Can? Okay.
Sure.
Yeah, say.
If I just do like what, like you just
Did
um
without writing the bracket, is it?
Yes, without writing the bracket. So I just put the answer, then put plus plus. Is it okay?
Yes, perfectly fine. The bracket is
Okay.
for me to teach one time, because if let's say, some students cannot do fast, right or not? They cannot do chonga. So we teach them a
Yeah.
little bit slower lah. Okay. So
Okay,
that's
because
the
this method is
faster.
easier.
Yes, I agree with you. I won't deny. But I really advise you, please draw this lah. Row and column. Draw one time, understand? Okay. Please draw that, the row and column. Wait, the screen is coming back, and you can see. Okay. Please draw this part here. I'm not sure why the screen is lagging today. Okay, the row and the column. Okay, please make sure you draw that. You can see the row and the column right there. So make sure you draw that. Okay, so that you don't go wrong. Understand? So that you don't go wrong. Okay, so done with that. Okay, how about D, E, and D now? If E and D over here, you can see this is a 3 by 1 and this is a 3 by 3. So can I multiply this thing? E and D there. Can I multiply this thing? 3 by 1 and 3 by 3. Can I multiply?
No.
No, I can't multiply. Why? Because 1 and 3, right? Not different, right? So we cannot multiply this. Okay, simple as that lah. Okay, very good. Done with that. Let's go on some more. Okay, we go on the next one then. The next one is transposition of a matrix. Okay, transposition of a matrix. Now, transpose matrix or transposition of a matrix is a process where the row and column interchange. So the row will become the column. The row will become the column. That is what we call transposition. Okay, or transpose matrix. You see, all the rows become the column. All the rows just become the column. So it's not that hard. It's just transpose the matrix now. Transpose the matrix means all the row you change it to column. Here, so you see row become column, row become column. You can see that? Okay. Row become column, row become column. So some people might ask me, sir, can be column become row? So like, yes, can. If you take 2, 7, oops, sorry. If you take 2, 4 here and you change this to column, can 2, 4 here is a column, become row, can what, right? Or you can see 2, 7 here is a column, you change it to row, also can. Understand? So row become column or column become row, also is the same thing lah. Not much difference over there. Clear? Is the same thing. But then we have properties of transposition. Okay, so the properties of transpose is very, very important lah. Okay, we can say that two transpose matrix, if you plus together, okay, here are two transpose matrix, you plus together or you minus together, okay, is the same as you taking the transpose and plus and minus the transpose. Okay, separately means you plus first, then you transpose, or you transpose first, then you plus, is the same thing. Okay, and if you transpose 2 times, okay, A transpose again, then it becomes like A lah. Understand? If A transpose, you transpose back again, it will become A again. And if you have a product, okay, A, B, then you transpose is the same as you taking the B transpose and A transpose, means B transpose and A transpose, means terbalikkan this A, B lah. A, B, just now we multiply A, B, now we will multiply B transpose, A transpose. Of course, the last one there, if the scalar doesn't affect the transpose at all. Understand? The scalar matrix doesn't affect the transpose at all. You just multiply before or after is the same thing. Clear with that? Okay. Now, why do we study all these matrices now? Because of this lah. We want to learn how to find determinant, and then after that, carry on to find inverse. Okay. So before we find determinant, we need to know what is our minor and cofactor. This is what you have not studied lah. Okay, you got study how to find determinant, but you never study how to find minor and cofactor. And you only study how to find determinant for 2 by 2 matrix. Okay, so you straight away use the formula of AD minus BC, yes or not? Okay, determinant in form 5 you study is AD minus BC. Right now is the similar thing which we are going to do, but for more than 2 by 2 matrix, which is 3 by 3 matrix lah. Okay, which is 3 by 3 matrix. So determinant, symbol of determinant is modulus of A or DETA. Okay, det 8. Now note over here, determinant of A is a singular. If A is a singular matrix, then the determinant is 0. So remember, determinant of a singular matrix equals to 0. Very, very important. Very, very important. Determinant of any singular matrix equals to 0 over there. Okay, so this is quite important. Okay. Now, let's see how, this is what you all have studied before in Form 5. Yes or not? You just take AD minus with BC. That is your determinant. Okay, that is 2 by 2 determinant. So that one, nothing changed. That one is still the same. To find the determinant of A over here, you just take 7 times 2 minus 4 times 5. Because A, B, C, D. So AD minus BC. Okay, so here is 14 minus 20, which is negative 6 then. Okay, I hope until here everybody okay lah. Okay, okay, done with that. Let's carry on next then. Now let's see what is the minor and cofactor here. Now this is more interesting lah. Okay, this is more interesting. Now I will go to example number 2 straight here. Okay, and I will do together with you. Okay, before we can move on. So let's see here. What is our minor and cofactor here? Okay, minor matrix here, basically, if they want the minor of 1, 2, okay, they want the minor of 1, 2 over here. Look over here, 1, the first row, the second column. So here, they want the minor of this. So what I will do here is, I will close off this thing here. You cancel off the lines over there. So the minor of 1, 2, the m of 1, 2 is just negative 1 times 7 minus with 4 times 2. Same like determinant. Negative 7 minus 8, negative 15. Then we got M22. If M22 here, let's see here, M22, the second row, second column. Yes, not 3 right here. So if I close off this, I'm going to get here 2 times 7 minus with 2 times 0. So I get 14 over there. That's it. And then M33, oh, where is M33? Okay, let's cancel off. Third row, third column. So here, cancel off. So this is what we cancel. So M33 over there is just going to be 2 times 3 minus negative 1 times 1. So I get 6 minus minus 1 plus 1, which is 7. So now you can tell me already the minor is there already. Now, not necessarily I must find only for minor of 1, 2, minor of 2, 2, minor of 3, 3. I can find minor of each and every element over here. Understand? You say I want to find the minor of M13. Okay, M13 is here. 0 here. Yes or not? So if I cancel off, I rub off here. 0. Here. So M13. Okay, this is very obvious. Negative 5 minus 6 over there, which is negative 11. You can go and find the minor of M21. M21 is here. Yes or not? This one, right? So this number, negative 1 there. So cancel off. This time you cancel off this. So this one you do with pencil line because you have to keep on rub, right? Not 7 minus 0 there. So you get 7. Okay, I hope everybody understand about minus. Any problem with minor there? Any problem with minor, class? Hello, any problem with minor?
Sir,
Yes,
is it like AD minus BC?
It is exactly like AD minus BC one. If you look over here, this is AD minus BC. Yes or not?
Oh, yes.
So it's exactly the same there. Clear? It's just that you have to know which is your AD and minus BC lah. So this time you will cancel off the lines lah. So you can very clearly see which is your AD minus BC lah. No, actually you can just close with your fingers. Yes or not? You
Yes,
put your blue color line one finger, you put your one more blue color line one more finger, you can do lah. But right now online, how I want to put my finger there? You cannot see finger there. Yes or not? Unless I draw the finger. Here put one finger, here put one finger. My drawing is very bad lah. Okay. So my mission is just to see which one to cancel off. Clear? Can
Okay,
I?
clear, sir.
Okay, very
Thank
good.
you, sir.
No problem. Okay, so we carry on some more. Now the next one there is going to be cofactor. Now cofactor, there is a formula actually. Okay, now let's pay attention. Hold on. I'm waiting for the screen to go off to the cofactor page. Screen is not moving yet. Hold on. Yeah. Okay, for cofactor. Ready, everybody? So for cofactor this time is more better lah. Okay, there's a formula here. The formula for cofactor is -1. Okay, power of I plus j, then mij. Now the -1 power of I plus j there is because of the sign which will be changing. Okay, when we want to change a cofactor sign, the sign will be plus minus plus, negative plus negative, and then here will be plus minus plus again. So if you notice over here, these are the elements which will change the sign. It will times with negative. The diamond over there will times by negative. Can see the diamond over there? So what is the element of the diamond over here? Oh, 1, 2. And then here is 2, 1. Here is what? 3, 2. And here is 2, 3. And if you notice the total number over here, 3, 3, 5, 5. Yes, not? All that is even number. Am I right? Okay, all that is even number. Am I right or not? Clear? Okay. Yes, see?
The even number, do we have to memorize it?
Yeah, if you can memorize, better lah. If you can memorize, better lah. This thing is fixed already. Clear? This thing is fixed. In a while, I will show you why if you memorize is better lah. Okay. Why? The reason is when you have 3, 3, 5, and 5 there, since it's even number, okay, any addition of the I and j, which is even, okay, sorry, this is odd number, my mistake, why I'm saying odd number, even number, sorry, again, my mistake, 1, 2, 2, 1, 3, 2, and 2, 3, that is odd numbers, yes or not? So all these are odd numbers. If it's odd number over here, -1 power of an odd number, okay, -1 power of an odd number will remain negative, yes or not? So the sign of the odd numbers, the sign, if the summation is odd, the element of the summation is odd, then it will be negative lah. Okay, for example here, if you look over here, I see the cofactor of C11 here. If you look at C11, it's the first element, first row, yes or not? So of course, you're going to find the minor first. You cancel off this. You find the minor will be 6 minus 7, 6 minus 10. 5 times 2 is 10, right? Which will be -4. Okay, which will be what? -4. But remember that 1 plus 1 is 2. So since it's an even number, you don't need to change the sign. Okay, since it's an even number, you don't need to change the sign. But if I go for C12, C12 here right now, C12 is here. So if I cancel off this and this, oh, I'm going to get here 2 times 6 is 12 minus 5 times 3 is 15. But the formula tell me because this is an odd number, you have to put a negative in front here. So negative 3, which will give me 3. So the cofactor is 3 over there. Can you understand that? Clear? So if I ask you for C22 right now, C22, no problem. Just cancel off over here. 2 is here. So this and this you cancel. So from there, you get 1 times 6 is 6. And then 4 times 3 is minus 12 there. So 6 minus 12 is -6. Now, since 2 plus 2 is an even number, I don't need to change the sign. So I don't put a negative in front. So that is the reason of the even and odd lah. Because odd, -1 power of an odd number will remain -1. And -1 power of an even number will change the sign, become +1 then. Can you all understand that? So if I look at another one more, C32, C32 there is here. Okay, third element, third row, second column. So here, so now if I find the minor there is 1 times 5, which is 5, minus with 8. Of course, there is a negative in front. So -3, which will give me the answer +3 there. Can you all understand this or not?
Yes,
Okay,
can.
Hatta, saya ulang balik lagi satu soalan. Okay, hold on Hatta. Okay, maybe I give another one more question here. 1, -3, 4, 2, -1, 3, 4, 5, -1. Now, actually, it's not that hard. It's quite easy. Okay, maybe I give you, this is B. Okay, pay attention. Okay, now I ask you to find the cofactor. To find the cofactor, you have to find the minor first. You have to find the minor first. Okay, So if I ask you the minor of M12, okay, what is minor of M12 here? Oh, M12 is the first column, first row, second column here, right? So this one you cancel off. So this is what you're going to draw your line. Okay. So from there, you can tell me this is going to become 2 times negative 1. Okay. Minus with 3 times 4. Okay. So here you get negative 2 minus 12, which is negative 14. But what is the cofactor of C12 right now? Okay, cofactor, because it's 1 plus 2, which is 3. So will be negative 1 times by negative 14. So jawapan dia 14. Itu je. Senang tak? Okay, but if let's say I ask you the minor of 22 or M22, let's see the minor there. I rub off the line. Hopefully I can rub the line clearer, faster. Yeah, okay. I rub the line already. So M22 here is this part. Yes or not? So if you cancel off this and this, you're going to get negative 1 minus 16. So negative 1 minus 16 there is negative 17. And the cofactor of C22 is also negative 17. Why? Because 2 plus 2 is positive 4. Yes or not? Which is an even number. Even number there, you don't need to change the sign because negative 1, power of an even number is going to be 1. Understand that? But negative 1, power of an odd number, it will become negative 1. That's why we change the sign. And the sign will only change if you really look inside this diamond shape here. Because you only study for 3 by 3 matrix, right? Not? So you need to know until here only that it will change in the diamond sign here only. That's all. Clear until there, class?
Yes.
Any questions some more? I hope Hatta you understand that already. Okay, Hatta? Okay, so I clear with that already lah, eh? Okay. So that is the details which is going on over here. Let's see another one more over here. So we see M23 over here. We know that M23, okay, second row, third column, this one, we can solve off this. We can find M23 very easily right now. 0 minus 12, which is negative 12. Now C23, because it's an odd number, so negative 1 times with negative 12, which will give you 12 lah. Okay. Now if I ask you M12, okay, no problem. Rub. Let's see M12 is where? M12, first row, second column. So here. So M12 is this element, right? Not? Okay, first row, second column. So M12 there done. So negative 4 minus 3. So you get negative 7. So C12, because it's an odd number also, negative 1 times negative 7, which will give you 7. Clear? So that's all lah. Okay, so indirectly you can this one and this one change sign. All the diamond shape over here. So they draw so much, but I explain to you very fast lah, in a very easy method. Okay, rest all is just the same thing lah. Okay, so the next thing here to find the cofactor matrix. Before we can find a cofactor matrix, we have to find all the minor, and then we change the sign of the minor in the diamond shape. We change the sign of the minor matrix in a diamond shape over here. So if I look over here, okay, I know I can find the minor of A. The minor of A is going to be all lah. You have to do lah. You have to cancel 2, 3 times 6, 7 times 0. So 18, yes, not? So the minor of A is 18 there. The first one is 18. The second one, you cancel 5 times 6, 30. 8 times 0. Then the third one you cancel. Go and do again lah. Okay, 35 minus 24. So if 35 minus 24, I think it's going to be 9 there. Sorry, 11. My mistake. 11 there. And then after that, you cancel off this thing here. So next one now is 2 times 6, 12. 12 minus 28. Okay, 12 minus 28, negative 16. Okay, and then the next one there is going to be for the 3. So 6 and 32. So 6 minus 32, negative 26. And then the next one there, 0 there. If you cancel off 0. 7 minus 16 there. So 7 minus 16 is negative 9. And then after that, you cancel off the 8. I'm finding all the minor. 0 minus 12, so negative 12. So here 0 minus 20, negative 20. And the last one there, 3 minus 10, so negative 7. I already find the minor. Minor of A I got already. Okay, but I want to find the cofactor. So what must I find? The cofactor of A here, we put in a matrix form. 18, negative 30, 11, negative 16, positive 16, negative 26, positive 9. Then here will become negative 12, 20, and negative 7. So all of these, I change the sign. Can see that? Only that I change the sign. Cofactor is a matrix. Minor are not matrix. Minor are just number. Okay, minor is just the concept of determinant. That's all. Cofactor is a matrix. Understand? So they cannot ask you to find minor matrix. They only can ask you to find cofactor matrix over there. Clear? Okay. Okay. So cofactor matrix we can find, but minor matrix we cannot find. Clear until there?
So can I ask
Yeah,
something?
ask. Say.
In cofactor only using 3 times 3.
Cofactor matrix normally we use only for 3 times 3. Yeah. The 2 by 2 we don't use cofactor. We just use the form 5 method and solve the problem. Clear with that?
Okay, sir.
Okay, Amirul. Okay, okay, that's good. Okay, of course the form 5 method comes from the concept over here lah, but I don't want to go into that detail because no use lah, that's why. Okay, not say no use. You don't need to know lah. Okay, you can use the form 5 method to solve. So why not just use lah, something which you have learned. Okay, okay. So now we go on some more. Okay, here cofactor matrix done. Next one is to find the determinant. Okay, I don't think so. I want to go into this because if I go into this, I will not be able to finish. Okay, so the next lesson we will start from here lah, determinant. Okay, the next lesson we will start from determinant. Can everybody? Okay, so next lesson start from here lah. Okay, so Friday we will start from here. I hope everybody can be on time on Friday and we will be able to start from here. Okay, everybody enter here. Any problem? Okay, good then. Okay, I just have a request from all of y'all. If y'all can please like, share, and subscribe the YouTube channel. Okay, and the videos, not only this video, but all the other videos. Okay, so that y'all, I mean, we can get extra time a little bit. Okay, for this StreamYard thing. Okay, okay then. Thank you, class. Bye bye. See y'all next Friday. Okay.
Thank you, sir.
Thank you, sir.
Okay.
Thank you,
Thank you,
sir.
sir.
Thank you.
Yes, sir.
Thanks. Bye.
Yes, sir.